Universal Space Network. And they have a constellation of satellites that you'll see here in a minute called tracking and data relay satellites. We have traditional ground stations called the Goddard Network that are located around the globe. NASA has a couple of those. We mainly contracted that support out to a company called the Universal Space Network. The nearest facility we have is down at Walton, Virginia, so it's about three hours south of here. Goddard used to be a tracking station back in the day, but that was decommissioned back in the early 80s. Then we have the Deep Space Network, which communicates with all the interplanetary spacecraft, the rovers on Mars as an example. There are three major nodes in the Deep Space Network, one in Goldstone, California, one in Madrid, Spain, and another one in Canberra, Australia. So the combination of these three networks is what we do to collect all the data from the spacecraft as well as command and control the spacecraft, whatever the spacecraft may be. Next slide, please. Okay, so Orion is unique in that this is the first test of this vehicle that will ultimately go into deep space. We'll fly again here in a few years to take the route with it and basically have it in lunar orbit for about a month. And then we're going to go farther out, probably do an asteroid run, but ultimately we want to go to Mars. But the point of that in relation to the networks is it's going to use all three networks. We'll use the near-Earth network ground stations at Cape Canaveral when we launch. We'll do a couple of laps around the Earth before we go translunar, and we'll be communicating through the space network at that point. And then as the spacecraft goes farther out, we'll hand over to the Deep Space Network. So all those assets, all those various assets come into play as we continue to fly Orion. Next chart, please. Okay, so as I mentioned earlier, we're going to use what's called the Space Network, and this constellation of TDRS satellites, tracking and data relay satellites. And these are, as I said, ground stations in the sky, geosynchronous orbit. We have 8 operational TDRSs in 3 specific regions. There's a cluster over the Atlantic, a cluster over the Pacific, and a cluster over the Indian Ocean. So you might ask, well, why do you need these kind of 3 nodes? Well, if you're down at low Earth orbit where the space station flies about 220 nautical miles, the geosynchronous coverage has a little bit of a gap over the Indian Ocean. We call that the ZOE, or zone of exclusion. And so that's why you have to have some satellites there to kind of close that gap. But our main nodes are over the Pacific and over the Atlantic. Tomorrow, and you'll see this in a minute, we're going to be using a lot of these satellites and pretty much consuming a big part of the bandwidth that the Space Network can consume. We've also got 2 satellites that we've retired. They're in what's called super synchronous orbit, so basically they boost them a little bit higher out of the geostationary arc, and they're basically turned off. We're not using them anymore. So we've got the 8 operational guys and the 2 guys that have been retired. Next chart, please. Okay, so here's what's going to happen tomorrow. This is basically a little graphic of the flight. It's only a 2-orbit flight. It's pretty short. The main purpose of this flight is to test the heat shield. So what we're going to do is we're launching on what's called a Delta IV Heavy. It's the largest rocket in the U.S. arsenal right now. And we'll basically launch from Cape Canaveral. We'll do a couple of engine burns there coming off the launch pad to upper stage burns to basically establish the orbit. Then on the second orbit, we basically will boost the high point, or the apogee of the orbit, up to just a little over 3,600 miles. So to put that in perspective, as I said earlier, the space station flies in 220 nautical mile orbit. This is 15 times higher than that. It's a lot lower than the geosynchronous satellites, the TDRS satellites, which are at about 22,200 miles of altitude. So TDRS will be looking down, but it's still very high up. Now the reason we want to go that high up is we want to come back into the Earth very fast. And so we're testing the heat shield. This is the largest heat shield ever built. And we're trying to hit a velocity that's about 80 to 90% of what you'd expect if you're coming back from deep space. So you want to hit it with all that velocity, have all that heating, and basically ensure the heat shield works. It's pretty fundamental to getting the crew back. So that's the main purpose of the test tomorrow. Of course, we're flying in space, so we'll have an opportunity to test out all the various other systems on board the spacecraft. Communications being one of those. We have a special communication system on board that's designed for deep space, and so we'll be using that for the first time for the satellites. We've been testing it a whole lot here in the past couple of years, so we're very confident it's going to work, but you got to go fly and make sure things work, right? So that's what we're going to be doing tomorrow. So that's pretty exciting for the folks here in this room and myself who work this for a while. Next chart, please. Okay, so going back to the TDRS, both the Delta IV rocket and the Orion capsule will use the TDRS satellites. And the Orion upper stage will be with us, I'm sorry, the Delta upper stage will be with us pretty much the whole flight to make that boost up to the high point of the apogee, then we separate and we come back in. So we launch from the Cape, we have satellites over the Atlantic region that are communicating with the Orion and the Delta. Go around the orbit, we pick up the 275 satellite for the Delta only on the west, or I'm sorry, on the zone of exclusion in the Indian Ocean. We only have 2 satellites that are configured for this new communication system we're going to fly tomorrow on Orion. So we're kind of limited on the satellites we can use for Orion, but we can use 3 more satellites for the Delta, which is flying more of a standard communication system. We then come back around to the west. We pick up 2 satellites over the Pacific, and then on the next orbit, we come back around in that Atlantic region. That's where we have the big engine burn. That'll take us back up to, actually we can skip that one. We're going to be so high that zone of exclusion I mentioned is going to actually close. It's going to go away because our altitude is so high that gap in coverage basically shrinks down to nothing. So then we pick up the satellites in the Pacific region. The Delta will separate, burn up on its re-entry. Orion will come back down and splash down a couple hundred miles west of San Diego, and we'll actually be communicating with it when it's in the water. So it's going to be a pretty busy day for these satellites. Now, you'll notice that on these satellites, we're using various antennas. Well, we've got all these other satellites that are trying to use these services as well. So one of the challenging things about this mission is we're basically using up all the bandwidth. And so we had to tell the other folks like Hubble and even the ISS, you know, if you guys could just kind of throttle back on your operations on December 4th and not use a lot of our services, that would be helpful. So we worked with them quite a bit over the last few months in kind of integrated planning mode. And so we've got everybody satisfied that the other missions can do what they need to do, including the ISS folks and the 6 crew members we have on board, and still fly our missions. That's been one of the challenges we've had to deal with. Let's go on. I mentioned that we've got the satellites that are like ground stations, so they have the antennas that are actually looking at the spacecraft, the Orion and the Delta. But then they also have a separate antenna that beams the signals back down to Earth. And we have 2 ground stations that receive those. The main ground station is at White Sands Complex in New Mexico, just outside of Las Cruces. And then there's a ground station in Guam that's dedicated to talking to the satellites or getting data from the satellites that are in the Indian Ocean region. And there's a connection back to Guam with the data coming back from Guam, and then there's a direct connection over to Mission Control Center in Houston at the Johnson Space Center, where okay, so another thing we have to do is we have to verify the trajectory. And we can do that by a number of ways. We've got GPS on board the rocket and on board the spacecraft. And GPS data from on board will be part of the data coming down through the satellites. We can also measure the Doppler shift with a change in frequency due to the motion of the spacecraft, which allows us to determine the orbit and make sure we are on the proper trajectory. But we also want to have a means that's completely independent of the vehicle itself. So we use good old-fashioned radar. And we'll have several radar stations up tomorrow to do the tracking as kind of a 3rd layer of verification of the trajectory, if you will. We'll have Eastern Range radars at Patrick Air Force Base, which is in Cocoa Beach, Florida. It's called the Beach Radar. It's literally right on the beach. Very nice place to go visit. We have a radar out at Armstrong, NASA Flight Research Center at Edwards Air Force Base in California. And then we have another one at Ascension Island, which is in the middle of the Atlantic. So we'll be taking radar passes with those, matching that up with the data coming down from the spacecraft, and ensure that we're on the right trajectory. And I think that's about it. So, follow us tomorrow, right? You can follow us on Facebook. There's NASA TV, which is available online at nasa.gov. We'll have full coverage of the mission. The media outlets should be all over it as well. So we're pretty excited. Yes, so questions? Yes, sir.
Now, you will be using a different control room in Houston than the International Space Station.
Yeah, it's in the same building, it's just down the hall. And I should point out, so this station, this room here, the Network Integration Center, we're basically the interface between White Sands, Guam, and Mission Control Center Houston and the radars. So we're basically orchestrating all of that communications infrastructure, feeding that back to Houston, and as a team we go off and execute the mission. Houston's more responsible for the spacecraft, the folks in Florida are responsible for the rocket, and then we're responsible for the communications infrastructure. Yes, sir.
So I understand that you're able to maintain your own television during reentry, you're able to maintain communication all the way down, but this time you're not going to be able to provide. Is that right? Or can you speak to that?
Yeah.
Blackout?
There was minimal blackout during shuttle because of the fact that there were antennas on top of the orbiter that could basically see through this superheated plasma that occurs as you re-enter. You don't have that on the Orion. The antennas are mounted not on the heat shield, but right above it along kind of the base part of the column. And so those get pretty much enveloped in the plasma and basically kind of block the signal. So it was kind of a factor of the geometry of the antennas that the shuttle allows us to do that with the same principles right back.
So will all of the seats in here be full tomorrow?
Pretty much, yeah. We're going to have a full team. We've got a team that's associated with just maintaining communications with the Delta rocket. We've got a team that is associated with just looking at the telemetry and